Welcome to Mathematics 123. Our focus today will be compound interest, which incorporates components from algebra and exponentials. Modern society application for mathematics is most visually noticed and observed through the handling of money, cash, and currency. With people partnering up with banks to keep their money safe, they are making the decision to grow their money. This is called investment. When individuals place their equity in the bank uses money for other things. This lending to the bank leads the money to grow by a fixed interest rate. This amount of money grows for a period of time, and the interest rate is counted as per annum or annually. The interest rate causes the invested amount to compound, meaning that the added amount from the interest is added on top of the invested amount, which is then compounded as a whole until the next period. This is called compound interest. The formula is given in the form of A equals P times 1 plus I to the power of n. The main difference between the compound interest and the simple interest is that n is taken out of the equation and as an exponential. This is due to n being the compounding nature of the rate. As shown in the graph of the table below, it shows the increasing amount of compounding nature of the rate on the amount of n. A being the final amount, P being the principal or invested amount, I the interest rate, and N the period of time. Banks are not just useful for keeping our money safe, but also for growing them. For example, when we put $1,000 in bank with a fixed interest rate of 7% per annum that compounds monthly at the start of May 2010, and we draw it 7 years later, the amount would have grown considerably. The graph below shows the increase of the interest rate on the principal being the blue and the green being the added interest rate. It shows the increases every 12 months or yearly, with the first period being P times 1 plus 7 divided by 12 to the power of 12 months, and so on, to the last and final year. So we put it into the formula with P equals 1,000, with the interest rate 7% divided by 12, which is the monthly nature of the compound. The n is 7 times 12 equals 84 to the months, and leading to A equals 1,000 times 1 plus 7 divided by 12 to the power of 84. This will give an amount of $1,629.99, nearly growing $630 as shown in the table. So in conclusion, compound interest is necessary for those people delving into keeping their money safe in banks, as well as bankers who keep them safe. The compound interest formula incorporates both algebra and exponentials learned from mathematics. Algebra for the variable values and exponentials for the rate of growth in terms of time. Thank you.